Okay, let's give you guys some more practice. So, given this data here, let's say I just performed an experiment and I collected the following data here. Can I, looking at this data here, can I truly say that y is directly proportional to x? So, what that means is, can I, well, visualize this here. If it's directly proportional, if y is directly proportional to x, then you have a straight line. I don't know, something like this, or it could be something like this. Um, well, the thing is, do all these points here, do they all lie on the same line? You see, if they all lie on the same line, then they are direct. Then you can say that y is directly proportional to x. If you have something like this, oh, 1 point here, 1 point here, and one over here, then you cannot say that y is directly proportional to x. Well, anyway, do whatever you have to do. Is can I say that y is directly proportional to x? Okay, so press pause and have a go. Okay, so if let's just say if y is directly proportional to x, then we can say that let's just say if, okay, if y is directly proportional to x, then let's have a look at the first point here. 13.4. I'm going to guess 13.4 to be around here. 13.4. 6.7. I'm going to guess to be around here. Okay, so this here is our 6.7 here. So the first point is here. Okay, now if y is directly proportional to x, let's just assume that that y is directly proportional to x. Then we're going to have a straight line like this, and all these points here should lie on this line. So let's just come up with an equation for this line here, because once we have the equation, it's really easy. So it's a straight line, so it will be y equals mx plus c. But because it goes through the origin, we can forget about c, because c will be 0. So it's just a matter of us working out the gradient. Well, the gradient, let's just use this point here for convenience. The gradient is well, the up and down here is is uh, is 6.7 here, okay, and the across here, to work out the gradients, it's always the up and down divided by the across here. So the across will be 13.4. Okay, so our equation is actually y equals 6.7 over 13.4x. Okay, so now let's check this point here. Now let's put this x into the x here. Okay, into this x here, and then we can put the y here into this y here. Okay, so let's just see if it lies on this line here. Okay, so let's have a look at the x here. Let's put this x into this x here. So y should be hang on, let's put 23.4 into the x here. So it gets multiplied to the top. It gets multiplied to the top. So it will be, hang on, calculator. It will be 23.4. It gets multiplied to the top. So times 6.7 equals this, and then divided by 13.4. Now, if it truly lies on this line here, then our y value should be 11.7. So this here, if it's 11.7, then it will lie on the line. Yeah. So it will lie on that line. So 23.4 here. This bit, it does actually lie on the line here. So 11.7. So it lies on the line here. So now if we extend this here, okay, let's just say now have a look at this point here. Let's say 776.8 is here. Does it actually hit? Is this value here, the y value here, is it 38.4? Okay, so now let's, oh, it's getting messy now. Hang on. This is our equation here. Let's use this to check this point. Does this point lie on the line? So now put this point here. Hang on, let me clear everything. So our equation is 6.7 over 13.4 x. Okay, now let's look at this point here. Put this into the x, and does y equal this? If it does, then it will lie on that line. So calculator, clear it. 6.8 times 6.7 equals this, and then divided by 13.4 equals this. So yeah, so here when we put this number into the x here, the y value does actually equal this. So there, 38.4. Then you know that this point here actually lies on that line. Okay, it does actually lie on that line. Now let's check this point here. Hang on, let me clear this. Remember, our equation is 6.7 over 13.4 x. Okay, now put this into the x here, and then let's see if y truly equals this. Okay, so calculator, clear this. Our x value is 92.7. Now times it to the top, 6.7 here equals this, and then divided by 13.4. So the y value is this. You see, if it truly lies on that line, then y should equal y should equal 46.35. But the y value here is, so this point here is not on that line. Okay, so our graph earlier was like this. The first point here lies on the line. This point here lies on the line. This point here lies on the line, and this point here, you see, if it truly lies on the line, then the y value should be 46.35, but it doesn't. The y value is somewhere up here. So the last point here, it doesn't lie on this line here. So you cannot say y is directly proportional to x, because if y is directly proportional to x, then all the data points should lie on this line. But then you've got one point here where it doesn't lie on the line. So here you cannot say that y is directly proportional to y. Yeah, y is directly proportional to x. Sorry.